Hello students. So let's try to solve one more problem from Jest 2021. And this problem is from again part A, question number 17 of the set D. And this problem is basically from central force problem. So problem is very simple. There is a particle of mass m and angular momentum L is given. So m is the mass of a particle. L is angular momentum. And it is also given that they are interacting with the potential Vr is equal to K ln R. So this is a central potential Vr is equal to K ln R. So what we have to do, we have to calculate the radius of a circular orbit and we have to check whether this radius is stable or unstable. So let's try to go for this particular concept. So we can easily use the concept of V effective. So what is V effective? So V effective is basically they are L square upon 2mr square, where L is angular momentum. So this is rotational kinetic energy plus Vr. And Vr is the potential energy, and this is given K ln R. So that will be L square upon 2mr square plus K ln R. And for the circular orbit, for circular orbit, we have del V effective upon del R is equal to 0. And from there, we can find the radius of our orbit. And that value can be easily calculated as minus L square upon mr cube plus K upon R must be equal to 0. And from there, we have R square is equal to L square upon mk. And this is at R is equal to R naught, and R naught is basically radius of a circle. So this is R is equal to capital R, or you can take R naught. In the problem, it is given capital R is the radius. So R is equal to obviously root under L upon root under mk. From here, we can easily calculate the value of R. So at R is equal to R, we can write. So this is going to happen at R is equal to capital R, where capital R is the radius. Now we have to check whether this orbit, which is circular in nature, are stable or unstable. So for the stable orbit, V effective should be minima at R is equal to capital R. So what we have to do, we have to just go for second order derivative, that is V second order upon del R square. And we have to check what will happen at R is equal to capital R. So when we are going to differentiate it, then this value is minus plus 3L square upon mr4, and this value is minus K R square. And we have to just check what will happen at R is equal to capital R, and that value is L upon mk. L upon root under mk. Now we have to put this value. So when we will put this value, so obviously R square is equal to L square upon mk. So when we will put value, so del square V effective upon, and that is R square actually, that is R square upon del R square at R is equal to capital R. Then we have 3L square, this is L square is there by M, R4 is there, that means we have L4 M square K square, minus sign we have to take, and we have to just put minus K upon R. So this value is K upon L square, and we have mk. So when we are going to calculate this particular thing, then we have You can easily calculate this particular algebra. So del square V effective upon del R square at small r is equal to capital R is equal to, so this value is equal to, we can easily calculate m k square by L square 2 times. So 2 mk square upon L square. And this value, m is positive, k square is positive, L square is positive. So this value is positive. So at r is equal to capital R is the minima, and it is also identified as stable equilibrium point. So at r is equal, so you can write in a summary that r is equal to r is basically stable equilibrium point, and the r value is equal to L upon root under mk. So I think this will be the answer, and this answer is D is the correct option for given value. So this is quite a simple problem, but yes, you have to always work with the concept of V effective whenever the nature of circular orbit or other type of orbit can be discussed, because it's a very important concept. And you can easily see when we are calculating this particular thing for the circular orbit, this is nothing but the equation of motion. This is centrifugal force is equal to external force. So we can easily get this particular equation of motion in this particular thing, and we can solve all particular step to getting the stable orbit or unstable orbit. Thank you.